out of these like foam cylinders. They're kind of like pool noodles that we found at Home Depot, and they have a perforation in the middle so that it's easy to cut, and we're cutting them open for most of the roller coaster so that the people who are sitting inside can look up and look out. So we also have two poster board. We had to glue them together because our roller coaster is going to be pretty big.
In order to start the ride, you must first get the ruler at 8.5 inches at a 62-degree angle and then release.
So it's been a while since we checked in, but the roller coaster is done now. So we start off, and it starts up at the top with a whole noodle because we had to get a lot of acceleration for it to get up the loop, because with this material it's pretty stiff and so it kinks up really easily, so we had to make sure that it stayed smooth. So we have a big, super huge hill of some sort. It goes up and down the loop, up a hill. This part's not assembled yet, but this is another hill, and then it's going to land into a pile of water. So we're trying to cover up the ugly duct tape with paint, and so now we're just painting it with acrylic paint and getting all of our measurements down. So that's about it. Okay, so we are just gonna do a dry run through of the marble going through. So based on our research, roller coasters date back to Russia, where sledders went down different ice slides that were made out of wood, and they were up to 70 feet high, and this was in the 16th century. And so the first actual roller coaster was in 1884 in New York's Coney Island. Coaster, we have lots of different energy transformations. We start off with kinetic energy at the top, and then in the middle of our first incline, potential energy turns into kinetic energy. Then as you come down and start to go up the first loop, kinetic energy turns into potential energy. Then you go through the first loop and the potential energy turns into kinetic energy. Then as you go down and start to go up the first hill, kinetic energy from here turns back into potential energy as we get up the first hill. Then on the back, potential back to kinetic. This poster board isn't attached yet, but this is our next hill, and as it goes up, kinetic energy turns back into potential energy. And as it comes down the last hill, potential energy turns into kinetic. So the potential energy is the highest at the top of the roller coaster where the marble starts, because it has all this way to go down where it gets turned into kinetic energy. So there's a lot of acceleration that happens here, and the velocity is constantly increasing. The kinetic energy is the highest also at the bottom of this first incline, because since the incline was so steep and so long, it gains all this acceleration to be able to get through the first loop. So everybody knows that the best time to ride a roller coaster is at night, and so that's why we should have this roller coaster in Six Flags, because it's called Starry Fright, and so basically you're meant to look up at the stars and do it at night so that it's so much scarier.